Hey guys, it's Ms. Johnson and I'm here to bring you our notes for Unit 6 Learning Target 1. Today we are talking about scientific notation. So scientific notation is a method that we use to write numbers that have many decimal places in them. We write them in a more condensed form. So we take really long numbers, either really small or really big, and we write them out in a more shortened notation so that they're a little bit easier to write. We use base 10 because that's what we are using, or that's what happens when we move our decimal point one place, is a factor of 10. So it's base 10 in scientific notation. So let's just do some examples. We're going to practice both directions. We're going to look at numbers and then write them in scientific notation. Then we're going to look at scientific notation and expand them out into their standard form. So let's start with looking at some standard form numbers. So we have the number 1,329,000,000 here, and we want to write it in scientific notation. So what we want to do is think about where the decimal point starts. Right now it's at the end of your number. And where we want the decimal point to be. What we want is one digit in front of the decimal point, okay? So we're gonna take our decimal point from the end over here all the way over there to the very beginning where there's just one digit in front. So that's kind of a note that you could make. One digit in front of decimal point. Okay, so now the process is count how many times you move that decimal point. We're gonna move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places, okay? So we moved 9 places, and here's what that does to our scientific notation. So we wanna write out the number part, 1.329, and then we're going to multiply that times 10. There's our base 10 that we were talking about, raised to the number of times we moved our decimal point. So since we moved our decimal point 9 times, we raise it to the 9th power. So it's 1.392 times 10 to the 9th power. That is your scientific notation. Okay, so however many decimal places you moved, that becomes your exponent. Okay, and then it's always base 10. That's another kind of note that you can make. Always base 10. And then exponent is number of places moved. So now let's talk about a really small number. In number 2, we have 0.000068. So right now, again, we want to start by looking at where is our decimal point currently and where do we want it to be. We want one digit in front of the decimal point. That means I need to move it all the way there between the 6 and the 8. So then the question becomes, how many times do I move it? I move it 1, 2, 3, 4, 5. Now here's where things are a little bit different, okay? This is a really small number, okay? A really small number means that I actually need to treat this as a -5. I moved to the other direction. I moved my decimal point to the right. So that means this is a -5 because I'm looking at a really small number. So the way I would write this is 6.8 times 10 to the -5th power. So again, you take the number part, that's what goes in front. It's always times 10. And then you raise it up to the number of places that you move it, okay? And that's your scientific notation. Some people like to set up this little template. They like to put a number times 10 raised to a number. And they know they need to fill in this spot and they need to fill in that spot. So if that's a little template that you want to set up for yourself, just know that those are the 2 places that you're filling in. What's your number that's being multiplied and how many places did your decimal point have to move? Okay, let's do a couple more. So I have 2.456789102. So I am going to, again, start by considering where is my current decimal point and where do I need it to move, okay? So there's my decimal point, there's where I need it to move. Now, here's a case where you might consider doing some rounding. The whole point of this is to shorten up how we write out our number. So maybe this is one where we round just a couple of places out. So this 6 would tell my 5 to go up to 6, okay? So I'm gonna write my initial number as 2.46 and call that good. Then I have times 10, and now I need to go back and figure out how many times did I move my decimal point. I'm over here at the end, so I'm gonna go 1, 2, 3, 4, 5, 6, 7, 8. Again, it's 9 places, and that's a really big number. Okay, that's 2,456,789,102 is what that number is. So 2 billion is a very big number. That means I have a positive exponent there. Now let's take a look at the next one. So in number 4, I'm back to a really small number. Here's my current decimal point. Here's where I want my decimal point to be. So let's see how many times we have to move. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I moved 11 times, moved 11 places. And I moved it to the right, which tells me that now this is my number, 8.9 times 10 to the negative 11th power. That negative 11 is what's going to tell me that if I were to expand this, I would expand it back to the left, because I know that I don't want 8.9. I want this really small number, which means I need to have a bunch of zeros in front of the 8 and the 9. So that means I need to move my decimal point back to the left. So really big number, that's kind of how I think of it. Large number equals a positive exponent. Small number equals a negative exponent. And by small number, I mean less than 1. Okay. All right, let's do a couple more. So again, in number 5, I'm going to do some rounding here. That's a whole big long number that I don't need to write out the whole thing. I'm going to go ahead and round it to the 7. I'm going to use the 8 to round the 7, and the 7's going to tell, or the 8's going to tell my 7 to go up. So that means I have 3.68 after I round it. And now let's count our decimal places. Currently, my decimal point's at the very end. I need to move my decimal point up all the way up there so that there's 1 digit in front. So let's count our places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I moved it 12 times, so that's times 10 to the 12th. Let's take a look at number 6. So in number 6, I go all the way over to here. Currently, I'm right there. I'm going to move all the way over there. It's a really small number. It's way less than 0, so I'm going to have a negative exponent here. So I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means I have 4.6 times 10 to the negative 10th power. Okay, so now let's talk about going the other direction. Let's talk about how we would convert these to standard notation. So if I wanted to convert these to standard notation, that means I need to first take a look at what is my power raised to. My power is raised to a positive 5 there. I've got 10 to the positive 5th power. Okay, so that positive 5 tells me that I'm going to have a large number, a number bigger than 1. So that tells me that I need to move to the right with my decimal point, okay? Because that's what's going to give me a larger number. So I'm going to take this decimal point right here, and I'm going to move it out 5 places. I go 1, 2, 3, 4, 5. Now, these last 2 that don't have a digit in them, I'm going to fill in with zeros. So my number looks like 3, 2, 6, 7, 0, 0, and then I come back and put in my comma. That's 326,700. Okay, so let's take a look at number 8. Now, my exponent here is -3. So that means I'm looking at a really small number. So that means I'm going to move my decimal point the other way. Move your decimal point so that it reflects a small number, which in this case means I need to move to the left. So I have a decimal point right here. I need to move it left 3 places. So I'm going 1, 2, 3. There's my decimal point. Fill in your spots with zeros. So I have 0.004567. Okay, so in number 9, my exponent here is a +7. So that means I have a large number again because it's a positive exponent. So that means I'm going to move to the right. So my decimal point's right here. I need to go out 7 places. So I go over for the 5 and then 1. So that was 1. So 2, 3, 4, 5, 6, 7, 0, 0, 0, 0, 0, 0. So it's a 4 and a 5 and 6 zeros, which is 45 million. In number 10, I have a power that is -8. So that means I'm going to take my decimal point and move it backwards 8 places. So that's 1 there, and then 2, 3, 4, 5, 6, 7, 8. So that would be 1, 2, 3, 4, 5, 6, 7 zeros with a 3. So decimal point 1, 2, 3, 4, 5, 6, 7, and then 3, 6, 8, 7. All right, next one. Now I have an exponent of -2. So I'm going to take my decimal point and I'm going to go back 2 places. So that gives me 0.0295673 for my expanded number there. And when I expand the number, I don't ever round. When I'm going into scientific notation, sometimes rounding is necessary because the whole point of scientific notation is to make things more condensed, so we don't necessarily need all those decimal places. But if I'm going from scientific notation into standard form, I don't ever round it. I write all the decimal places out. So let's take a look at number 12. I have a +3 exponent, so that means I'm going over 1, 2, 3 places. So I still have a digit after the decimal point here. I have 5687.3. So 5687.3 is my number there. All right, that takes us to the end of our notes. Thanks for tuning in today, and I will catch you next time.